So for today, go ahead and set up your ECQs. This is on page IP36. The title is Physical and Chemical Changes ECQs, or you can write PNC Changes ECQs. Divide your paper in half for the questions on one side and the answers on the other side. Leave the answers blank until after your notes, but first we'll be taking down questions. Your 4 questions for physical and chemical changes are the following. I'm going to move this slide down a little bit for you. Go ahead, write that down, and move to the next slide when you're ready. Physical and chemical changes are on page IP37 for some Cornell notes. So setting up your paper Cornell style, you want to make sure you put the title on top. Again, this is page IP37. And set up your Cornell paper for areas for the essential question, vocabulary, and summary. Remember, you'll have to create a key for your highlighting at the end of your notes. Okay, we're going to go ahead and start. The essential question. Contrast the difference between physical and chemical changes. You'll have to answer this in your summary, so be ready to look for answers. Number 1, a physical change is defined as when a substance changes physical properties, but it is still the same substance. Physical properties include size, color, shape, and state of matter. So if something changes its size, or color, or shape, or the state of matter, it's usually a physical change. For example, the atoms in the substance are just moved around or rearranged in a physical change, and you might even be able to change back to the original material. So for example, you have a solid ice block here made of H2O particles. Each circle represents one H2O. And it's still there when it's liquid water. It's just melted, so now it is spread apart more. If it becomes gas, then it just basically is the same thing, but they're even more spread apart and fill up more space. So it's technically the same thing as you go from one state of matter to the next state of matter. Okay. Here is a more exact picture of H2O molecules stuck together. All the little Mickey Mouse heads are stuck together in a solid, become a liquid as they're more spread out and more free, and as a gas as they're the most free and most spread out. But each part is still the same, so it's just a physical change. You could even make it go back. You could make a gas change back into a liquid through condensation, and a liquid freeze into a solid, right? So it can change back and it's still the same thing, it's just a physical change. Some other examples is a broken pencil. It's just 2 pieces, but they're still the same thing. Or a melted popsicle. When it goes from a solid to a liquid, it's still the same thing. It's just melted, right? So it's just a physical change. Likewise, melting ice to water, still the same thing like we mentioned, and solid ice cream becoming liquid, it's just the same thing. It's just a physical change. So when we made ice cream in class, going backwards from milk to ice cream, that's just a physical change. There was no chemical changes of anything. It was still milk. We still had vanilla. We still had sugar. It was still the same thing, just mixed up and frozen. A chemical change is different. It's the change of one substance into a new and different substance. And this is one main key difference between physical and chemical changes. For example, you have a little white hydrogen atom stuck together and oxygen atoms stuck together. When they go through combustion or a burn, you actually can create water molecules. And each one has 2 H's, 2 hydrogens, and 1 oxygen atom stuck together. This Mickey Mouse molecule is different from this one over here, which is just oxygen by itself and hydrogen by itself. You cannot breathe this red oxygen from water. You would suffocate if you tried to do that. So it's different. It's a chemical change. Signs of a chemical change. There are actually 5. The first one is production of an odor. Some examples is when we have fire, or when you're cooking, or when food goes bad. It smells different, and that's a sign of a chemical change. You can't go back. Bad food cannot go back to being good food. You wouldn't eat it or just, cook it or somehow make it good again. It doesn't work. When you cook food, Foods that are cooked are now different from the raw food. It's no longer the same thing. You would probably eat a cooked steak, but not a chunk of raw steak. Same with when you burn something in a fire. When you burn something, it becomes ashes and smoke, and it's no longer able to go back to being the tree or wood or paper that it was. A second sign of chemical change is the production of heat and or light. This is when there's a temperature change. So creating fireworks, explosions, burning paper, burning anything creates a chemical change because, again, it cannot go back to what it was. It's no longer the same thing. Paper that's burnt is not the same thing as regular paper. Burnt paper is now ashes and smoke. You can't put the ashes back to make paper. A change in color is an example of a chemical change too. So rotting food, rust, and leaves changing colors in the fall are all chemical changes. These leaves don't come back. They actually fall off the tree, as you know, and they're then considered dead. They don't come back to the tree. The tree can make new leaves, but this particular leaf won't come back. Rust itself is a chemical change. It's not just a color change because the rust actually destroys the metal. It corrodes the metal. So if you've ever had, if you have a car at home and paint gets scratched and rust starts to form, it is a big deal because it can destroy your car's body. Rotting food also is definitely a chemical change. This change in color is not something that you can just get rid of and still eat. Yeah, when food is rotted like this, you don't want to eat it. Formation of bubbles is also a sign of chemical change. In both cases here, they create carbon dioxide gas that was not in the water before. That was not in the vinegar, it was not in anything. It was created out of the mixture of baking soda and vinegar. But you gotta be careful. Boiling water is not a chemical change. It's a physical change because the water is only changing from a liquid to a gas. You're just getting bubbles of the same H2O, but they're now gases. So be careful. Just because something is bubbling does not mean that it was a chemical change. Same with our dry ice in our class. Remember the dry ice lab? The bubbles that were created from our colored water and from the dry ice pieces, that was just a physical change because it was still dry ice, it was still carbon dioxide that was solid that turned liquid, and it was still water. It just looked cool, but it was not a chemical change. The last sign of a chemical change are the formation of a solid, or as we say in science, a precipitate. Some examples would be like the shells of clams and mussels that are formed when a liquid from the animal combines with seawater. The shells have ridges, and each ridge is formed from the layers of solid pieces or solid precipitate that the mussel pieces have created inside, that the animal inside made to protect it. The shell wasn't there at first. They had to build it and grow it. And as it got bigger, the shell would get bigger too, so you can see the layers. That's it for our notes. We're done. Go back and make questions for each section of your notes. You can use these words. Please do not use what questions. So no what is, what are questions. Then go back with your highlighters and make a key for your highlighters. Highlight vocabulary, any definitions, and any important facts that you think will be on the test. And then create your summary at the end with vocabulary words on the bottom left corner and summarize your notes by answering that essential question from the beginning. Incomplete sentences. When you're done, raise your hand and make sure you get your notes signed for the day. And that's it.